back to part 2 of section 3.3. Let's get started talking about our algorithms for subtraction. Our first algorithm is called our concrete model, where we use our base 10 blocks. This model is going to use our set theory. So here we have 243 minus 61. Our minus tells us that we are taking away. And the number that comes after the minus tells us what we are taking away. So here we're taking away 6 longs and 1 unit. I start with 243, or 2 flats, 4 longs, and 3 units. Now remember, I have to take away 6 longs. I only have 4 longs, so I don't have enough longs to take away. We talked earlier that 1 flat is equal to 10 longs. My first step is I'm going to trade 1 flat, so that gives me 1 flat left, for 10 longs. 10 plus 4 gives me 14 longs, and don't forget to bring down your 3 units. I can now take away 6 longs. I have 3 units. I want to take away 1, so I have enough units to take away. So my second step is to take away or subtract 6 longs and 1 unit. I have 1 flat, 14 minus 6 is 8 longs, and 3 minus 1 is 2 units. The flats represent the hundreds, so we have 100. Longs represent our tens, so 80, and then the units represent our ones, so 182. Let's look at another. Again, our subtraction here tells us we are taking away. For this problem, we're going to take away 1 flat, 8 longs, and 9 units. I start with 357, so 3 flats, 5 longs, and 7 units. I need to take away 8 longs, so I don't have enough longs to take away. 1 flat is the same thing as 10 longs. So first, I trade 1 flat, leaves me with 2, for 10 longs, and 10 plus 5 gives me 15 longs. Don't forget about your 7 units. I also have to take away 9 units. I only have 7. 1 long is the same thing as 10 units. So my second step is to trade 1 long, leaves me with 14, for 10 units, so that gives me 17 total units. Bring down your 2 flats. Now I'm ready to subtract. So I can take away 1 flat, 8 longs, and 9 units. 2 minus 1 is 1 flat. 14 minus 8 is 6 longs. And 17 minus 9 gives me 8 units. Our flats represent hundreds. We have 100. Our longs represent our tens place. And our units represent our ones place. So 168. Our next algorithm is called the equal addition algorithm. This one relies on the fact that subtraction between 2 numbers doesn't change if we add the same amount to both numbers. So what we're trying to do here is to get multiples of 10 or multiples of 100 to make the numbers easier to subtract. In this example, we have 255 minus 163. Well, for some children, this may be difficult to subtract. So how can I get 163 up to a multiple of 10? Well, I need to add 7. If I add 7 to the second number, I need to add 7 to the top number. Now, you'll notice I put the 163 plus 7 in parentheses. That minus would be distributed to both terms, so a plus 7, distribute the negative, makes a minus 7, cancel each other out. And when I've added the 7 like I have not changed my problem. 255 plus 7 is 262, and 163 plus 7 is 170. Well, for some children, this still may be difficult to subtract. So can I get 170 to maybe a multiple of 100? Sure. If I add 30 to 170, I get a multiple of 100. I actually will get 200. If I add 30 to the second number, I need to add 30 to the first number. Again, notice I've put 170 plus 30 in parentheses. When I distribute the minus, a plus 30 with the first number, distribute the minus, makes a minus 30 with the second number. I haven't changed the problem. 262 plus 30 is 292. 170 plus 30 is 200. And now when I subtract, I get 92. Let's look at another example. Here we have 382 minus 145. Again, I want to try to make multiples of 10 or multiples of 100. I can make a multiple of 10 with the second number by adding 5. If I add 5 to the second number, I need to add 5 to the top number. Again, notice those parentheses, so I haven't really changed our problem. 382 plus 5 is 387. 145 plus 5 is 150, and these two numbers are fairly easy to subtract. Subtract your hundreds place gives us 2, 8 minus 5 in the tens place is 3, and 7 minus 0 in the ones place is 7 for 237. Our next algorithm is called the counting up algorithm. This is typically used by cashiers and tellers to make change. Now today with calculators and computerized cash registers, you may not see the counting up algorithm used as often. It is also a way that we can do subtraction mentally in our heads. So we want to count up to our nice numbers, our multiples of 10, 100, etc. Let's get started with an example. Here we have 100 minus 31. So I want to count from 31, and I'm going to count up to 100. I'm going to first get to my multiple of 5, so 32, 33, 34, 35. Then I'm moving to multiples of 10, so from 35 to 40 to 50 to 100. So let's look at how far we've counted. Well, 32, 33, 34, and 35, that's 4. From 35 to 40, that's 5. From 40 to 50 is 10. And from 50 to 100 is 50. So 50 plus 10 plus 5 plus 9, that's 69. Let's look at another example with counting up. 50 minus 11. I start at 11 and I want to count up to 50. So 12, 13, 14, 15. I need to think about multiples of 10, so 20, and then 50. Well, 12, 13, 14, 15, that's 4. From 15 to 20 is 5, and from 20 to 50 is 30. 30 plus 5 plus 4 is 39. Our next algorithm is called the trades first algorithm. So we're going to think about making our trades, and we're going to make our table with our hundreds, our tens, and our ones column. So go ahead and draw your table with your hundreds, tens, and ones column. We have 100, 2 tens, and 2 ones. Our minus tells us we're taking away. So here we're taking away 3 tens from that tens place and 7 ones from the ones place. Now notice I don't have enough tens to take away 3 of them. So I'm going to trade 100 for 10 tens. So that gives me a total of 12. And bring down your 2 ones. Well, notice I need to take away 7 ones, and I don't have enough ones to take away. So I'm going to trade 1 10 for 10 ones, so that gives me a total of 12 ones. And now I'm ready to subtract or to take away 3 tens and 7 ones. 11 minus 3 gives me 8 tens, and 12 minus 7 is 5 ones for a total of 85. Let's look at another example. Draw your hundreds, your tens, and your ones column. We start with 4 hundreds, 5 tens, and 3 ones. The minus tells us we're going to take away. So I'm taking away 100, that's not a problem. I'm taking away 7 tens, I don't have enough tens to take away, and I take away 8 ones. Again, I don't have enough ones. I trade 100 for 10 tens, so that gives me 15 tens. Bring down your 3 ones. Because I don't have enough ones to take away, I'm going to trade a 10 for 10 ones, so that gives me 13 ones. Don't forget to bring down your 300s. And we're ready now to subtract 100, 7 tens, and 8 ones. 3 minus 1 gives me 2 in the hundreds place. 14 minus 7 is 7 in the tens place. And 13 minus 8 is 5 in the ones place for 275. Our last algorithm is the algorithm that you are probably most familiar with. It's called the standard algorithm. You may have learned the term borrowing, but the words we commonly use today are trading and regrouping because they more closely match what's done with our manipulatives. So our standard algorithm, we have 581 minus 192. Start with your ones column. I need to take away 2 ones, but I only have 1 to start with, so I don't have enough ones. I'm going to trade 110 for 10 ones. That gives me 11. So 11 minus 2 is 9. Move to your tens column. I take away 9 tens, but I only have 7, so I don't have enough tens to take away. I trade 100 for 10 tens, so 7 plus 10 gives me 17. 17 minus 9 is 8, and then 4 minus 1 is 3 for 389. In part B, we have 358 minus 179. Again, notice I don't have enough ones to take away the 9 ones from 179. So I trade 110 for 10 ones. That gives me 18 ones. 18 minus 9 is 9. Move to your tens column. I have to take away 7 tens, but I only have 4, so I don't have enough. So I trade 100 for 10 tens. That gives me a total of 14, because 4 plus 10 is 14. Minus 7 gives me 7 tens, and 2 minus 1 gives me 100, so 179. What happens if we try to subtract in a base other than 10? We've talked before about base 5. In base 5, 5 units make a long, 5 longs make a flat, 5 flats make a block. Or in base 3, 3 units make a long, 3 longs make a flat, 3 flats make a block. So in part A, we have 3, 2 base 5 minus 1, 4 base 5. Our minus here tells us to take away. What comes after that minus tells us what we're taking away. So we take away 1 long and 4 units. I start with my first number, so I start with 3 longs and 2 units. I have to take away 1 long. That's okay, I have 3, so I can easily take away 1. I also have to take away 4 units, but notice I only have 2. Now in base 5, 1 long is the same thing as 5 units because we're in base 5. So I'm going to trade 1 long for 5 units. So that gives me 2 longs left. 2 plus my 5 units that I traded for gives me 7 units. And now I'm ready to take away 1 long and 4 units. 2 minus 1 gives me 1 long. 7 minus 4 gives me 3 units. So I have 1, 3. And don't forget to write your base 5. Anytime you're in a base other than 10, you have to write that base as a subscript. Now notice I did not read this as 13 because I'm not in base 10. My place value is different in base 5. Let's look at another example. Here we have 232 base 4 minus 23 base 4. The minus tells us to take away. Behind that minus, we take away 2 longs and 3 units. I start with 2 flats, 3 longs, and 2 units from that first number. I need to take away 2 longs. That's not a problem. I have 3. I also need to take away 3 units, but notice I only have 2. So I need to make a trade. Now in base 4, 1 long is 4 units. So I trade 1 long, leaves me with 2, for 4 units. 2 plus 4 gives me 6, and bring down your 2 flats. And now we're ready to subtract 2 longs and 3 units. This gives us 2 flats, 2 longs minus 2 longs, no longs left, and 6 units minus 3 units leaves us with 3 units. So I have 203 base 4. Again, be sure to write that subscript of base 4. Anytime you're in a base other than 10, you have to write that subscript. Also notice I put that 0 in that second place. You have to have that 0 there to hold that place. That brings us to our mental computation. So we have our breaking up and bridging strategy where we subtract the first number minus the tens in the second number, and then we subtract our units. Here we have 67 minus 36. My first step is to say 67 minus 30. The 30 comes from that tens place. That 3 is 3 tens or 30. 67 minus 30 is 37. Now I haven't subtracted the ones place, that's 6 yet. So I say 37 minus 6 is 31. You'll notice here that I've written steps out to the side. On your quiz, if you have to show work with breaking up and bridging, you will need to show these 2 steps. However, children would do these steps in their head. Let's look at the next one, 76 minus 33. Again, I plan to use the breaking up and bridging strategy. So I start and I say 76 minus 30. So I focus on the tens place from that second number. 76 minus 30 is 46. Now I look at my ones place in my second number. 46 minus 3 is 43. And that's my final answer. On a show work question on your quiz, again, you'd show steps 1 and 2. But these steps would be done mentally by children. Our next strategy is the trading off strategy. It's very similar to the equal additions algorithm that we talked about earlier. The difference between the two is in the equal additions algorithm, you would be using pencil and paper. However, in trading off, the steps would be completed mentally. We have 71 minus 39. Now I want to make a multiple of 10 to make my numbers easier to subtract. So 39 plus 1 is 40. That's a multiple of 10. If I add 1 to the second number, I have to add 1 to the first number. Again, notice my parentheses. The plus 1 with the first number, distribute the minus on the second line. It gives me a minus 1. 1 minus 1, I haven't changed that problem. 71 plus 1 is 72, and then 39 plus 1 is 40, and when I subtract, I get 32. Just like I mentioned with the breaking up and bridging strategy, you will have to show the step on a short question on a quiz. However, these steps would be completed mentally by children. Look at part B, 137 minus 28. I'm going to try to make 28 into a multiple of 10. And so if I add 2, that gives me 30, which is a multiple of 10. If I add 2 to the second number, I need to add 2 to the first number. Again, notice those parentheses, so I haven't really changed my problem. 137 plus 2 is 139. 28 plus 2 is 30. And when I subtract, I get 109. Our last strategy for mental computation with subtraction is the drop the zeros. So here, I drop the zeros, I subtract, and then I replace those zeros to keep my proper place value. I have 8,700 minus 500 in part A. So I'm going to drop the zeros. 87 minus 5 is 82. Now remember, it was 8,700 and 500, so my answer is 8,200. In part B, I have 1,400 minus 300. Drop your zeros, so we have 14 minus 3, which is 11. Again, I started with 1,400 and 300, and so this is 1,100.